Hello, I'm Elaine Rosenberg from Neo4j, and we welcome you to this advanced training session that will teach you how to build full stack applications with Neo4j, GraphQL, JavaScript, and React. During the session, we try to use the chat for notifications, but primarily use the Q&A area for questions and answers. Hopefully you've set up your system so that you'll be able to perform the hands-on exercises of this session. They're posted in the top of the chat area. So let me introduce your instructor for today, Will Lyon. Will has been with Neo4j for many years. He's a software developer here at Neo4j and has built many applications that showcase Neo4j. One of its most recent projects is the ever-popular GRANDstack starter kit. Joining him as a TA will be Adam Cowley, another software developer here at Neo4j, who has worked in the field and with customers and is also busy developing example projects and applications to help developers integrate Neo4j into their applications. So welcome everybody, and Will, let's get started.
Okay, great. Thanks, Elaine and Karine, and hey everyone, welcome. Thanks for joining today. Before we dive in, a couple of things I want to mention. The first is if you look in the polls tab in Big Marker, you should see a poll there asking how familiar you are with GraphQL. And if everyone could answer that, that would be great. That can help us sort of gauge everyone's familiarity with the different tools we're going to talk about today. And then the other thing, I posted a message in the chat a few minutes ago that has a link to a GitHub repository, which is what you are hopefully seeing on the screen right now. All of our content for the workshop is in this GitHub repo. So you'll see the exercises and some of the code for what we'll be working on today. So definitely bring that up. You'll want to refer to some of the links in there and some of the content as we go through everything today. So to give you an overview, there's basically, let me zoom in a little bit here. Zooming in on the wrong thing there. There we go. To give you an idea of what we're going to cover today, so there are three modules for the workshop today. The first one is Neo4j GraphQL, where we are going to be sort of starting with an introduction to GraphQL and then quickly building up to seeing how we can use GraphQL with Neo4j. We'll use the GraphQL Architect Graph app for Neo4j Desktop. So you will want to make sure you have Neo4j Desktop installed. And then we will move on to Module 2, where we will be then looking at a full stack application using Apollo Server, React, and Neo4j. I will use this create GRANDstack app command line tool to start with a skeleton project and then see how we can get that working with the Neo4j sandbox instance and how we can deploy that to the cloud using Netlify. And then in the third module, we'll take a look at some of the authorization functionality that is available with the Neo4j GraphQL integrations. And we'll see how we can start to protect some of the resources in our API and add user-specific authorization rules. I think each one of these modules should be, between an hour and 90 minutes or so. We'll see how it goes. Hopefully we have time to get through everything. I think the plan is 4 hours for today. Cool. So let's take a look at the setup. Which hopefully everyone had a chance to go through this. If not, can get started now. So the first thing is make sure that you have Neo4j Desktop installed, which you can download here, neo4j.com/download. And then you also want to make sure that you have a fairly recent version of Node.js installed. I think anything greater than major version 12 should be good. And then we're also going to be using npm, the package manager for JavaScript. By default, that's installed with Node, so you should have that if you have Node installed. And if you're familiar with Yarn, you can also use Yarn as well. So good commands you can run to check that both of those are installed and what versions you have are just node-v and npm-v. We'll also be using Neo4j Sandbox, GraphQL Architect, GraphApp, the Create GRANDstack command line tool, and Netlify. These don't require any installation up front, so don't worry about that. That's more just for your reference. And there's one link that is not on this page, but I think we have it here. Oh yeah, and that is the GRANDstack documentation. So as you're working through the exercises and looking for some reference documentation for how to use GraphQL in Neo4j, that can all be found on grandstack.io. Okay, cool. So that is a rough overview. Let's jump into the first module. So again, you can find all the content in that GitHub repo that's linked in the chat. Let's take a look at our poll answer here. So hopefully everyone had a chance to answer the poll. If not, click into the polls tab and answer your experience with GraphQL. So we'll be focused quite a bit on GraphQL and using GraphQL with Neo4j. We'll take a look at React as well. So I might ask this question for the front end tools when we get to that section as well. So it looks like there's a pretty good mix here, which is good. So looks like about just under a third of folks are not familiar with GraphQL at all. Another third have gotten to the phase of writing queries, but not necessarily mutations or built a GraphQL server. Okay, that's good. And then about 40% of us have actually built a GRANDstack application, but maybe not shipped one to production. Cool, so that's a good mix. Thanks for answering the poll. That'll help us sort of guide the course of what we cover here. So feel free to ask any questions that you have in the Q&A tab or any thoughts in the chat as well. Hopefully we can keep this as interactive as possible. Cool. So so in this first module, I want to talk a little bit about a few things, how Neo4j works with GraphQL and that sort of thing. As we scroll through here, you'll see that there's a bit of content at the beginning, and then we jump into some of these exercise sections. So the goal for today is to be as hands-on as possible. I think this first session probably has the most sort of initial content to make sure we have sort of a level playing field to get started. But then don't worry, we will have designated time for jumping into exercises and being pretty hands-on. Okay, cool. So with that, let's start talking about Neo4j and GraphQL. So first of all, in this module, like I said, we're going to talk a bit about Neo4j, a bit about GraphQL, and take a look at the Neo4j GraphQL integrations. So the first thing we'll do after we talk a bit about what GraphQL is and how and why we should use it, we'll take a look at a demo GraphQL API that is serving some content about movies, and we'll see how we can write some queries to answer some questions against that. Then we will switch over to Neo4j Desktop, and we will use the GraphQL Architect graph app in Neo4j Desktop. So if you're not familiar with graph apps, they are sort of like extensions for Neo4j Desktop, maybe is a way to think of them. So single page apps that we can install within Desktop that allow us to interact with any of the databases that we have connected in Neo4j Desktop. And GraphQL Architect allows us to build, query, and deploy GraphQL APIs just by writing type definitions. So it's a good way to see how the Neo4j GraphQL integrations work without having to write a lot of code. I like to refer to it as a low-code GraphQL tool. Okay, so that's the goal. That's the goal for this module. It should take us maybe about an hour or so. So first of all, what is Neo4j? Well, I think we can largely gloss over this part. The point I want to make here, though, is Neo4j is this core piece of the database, but there's this entire ecosystem around the database, right? So depending on what you're interested in doing with Neo4j, there's tools for graph analytics, like the Graph Data Science library. There's visualization tools like Bloom that allow us to interpret the results of those algorithms. On the other side, if we're building applications, maybe we're interested in more transactional workloads, and we're interested in maybe running Cypher queries using one of the Neo4j drivers, like the JavaScript driver, the Python driver, to build our applications. And that's where the Neo4j GraphQL integration sits, is kind of in this drivers and APIs corner of the Neo4j Graph platform. So we're very much talking about building applications, building an API that sits between our client and the database. That is typically the use case we have for GraphQL when we're using it with Neo4j. Having said that, we can use GraphQL with, so for example, some of the graph analytics, graph data science library, and we'll see how we can do that hopefully today. Great, so that is how GraphQL fits into the platform, to the Neo4j Graph platform. Let's talk a bit more about what GraphQL is. So fundamentally, GraphQL is an API query language with a runtime for fulfilling those queries, right? So you can think of GraphQL as an alternative to REST. So we're talking about a way of building APIs. With GraphQL, we have a strict type system that defines the data that's available. The terminology that we use in GraphQL is types. So types, these are the entities, the objects, and fields are the attributes or the properties. So here we're defining a type project that has name, field, tagline, field. Those are both of type string. And then contributors, that is an array object of user type. So when we're talking about GraphQL, the graph piece is referring to how these types are connected in the type definitions. So we're essentially saying, in this case, that the project type has a connection to the user type called contributors. GraphQL operations, so to use GraphQL terminology, we say an operation instead of a query. A query can be a specific type of operation. So the types of operations that we have are queries, which are typically read-only operations, mutations, which are typically write operations, so creating, updating, deleting, and then subscriptions. Subscriptions are sort of like pub sub, where we're listening for some event to occur and being notified of that. So those are the three basic operations in GraphQL, and those operations define the entry points for the API. So any GraphQL operation is going to have an entry point and then a traversal of the data graph, which is called the selection set, that is defining what fields to be returned by the operation. So some important concepts in GraphQL. The first one is GraphQL type definitions. So we said that GraphQL has a strict type system where we need to define the data that makes up the API, so our schema, essentially. We do this using typically the GraphQL schema definition language, or SDL. So SDL is this language agnostic way for us to define our GraphQL schema. SDL is nice because we can use, we can build GraphQL servers in lots of different languages. We'll be using Node.js to build our GraphQL servers today, but there are GraphQL server implementations in lots of different languages. Java, Ruby, Python, Go are quite popular as well. So that's a nice language agnostic way for us to define our types. However, each of these GraphQL server implementations also have a programmatic way of building up these type definitions. We talked about this idea of GraphQL operations. So every operation is either a query, mutation, or subscription. And then we have in our schema special query, mutation, and subscription types. And then the fields of each of those query, mutation, or subscription types define the entry point for the API. So each operation starts at the field of one of these types. And by default, if we don't specify the type of operation, it's a query. So here's an example of a GraphQL operation. Zoom in a little bit. There we go. So we haven't named or specified the type of this operation, so that means it's a query. And we start with, in this case, movie. So what this means, this is referring to a field on the query type. So there's a movie field on the query type in this API that we're querying. And then we can pass along arguments to any field. In this case, we're passing along a title argument. So we're saying find a movie with the title A River Runs Through It. And then in the next part of the operation, we have our selection set. And the selection set, I like to think of this as specifying a traversal through the data graph, where the data graph is the GraphQL schema, essentially. And it's specifying not only how we want to traverse the data graph, so in this case, we want to go from the movie node to any actor nodes connected to any genre nodes, to any director nodes, and then from those director nodes to other movies. And notice here that we can pass along arguments to each one of these fields. So we're saying only grab the first two actor nodes that you find. Similarly for the sort of co-directed movies is maybe a way to refer to this. So so for the directors of A River Runs Through It, what other movies did those directors direct? We're saying only grab the first 3. So the selection set is very much this sort of nested collection of fields to return, and then also a way to traverse the graph. And then the response to our operation matches the shape of the selection set. So if we look at the fields that we requested in the selection set, any object fields, so actors, genres, those come back as nested values. Any scalars, so title, for example, comes back as a scalar field. Most GraphQL server implementations use JSON as a transport layer. That's not a strict requirement of the specification, but that is the common convention. Okay, and the last GraphQL concept that we want to talk about are resolver functions. So GraphQL resolvers are the functions that are actually responsible for fulfilling the GraphQL operation. So in the context of a query, typically what this means is fetching data from some data layer. So in most GraphQL server implementations, this is expressed as what's called a resolver map. So a dictionary or object of functions. And you can see here, we have sort of a mapping from the type definitions to our resolver functions. So every field for every type in a GraphQL schema has a resolver function. There's a default resolver, so we don't always need to create resolvers for every field if maybe the only operation we have is a simple object lookup. So if we are resolving a GraphQL query and we have an object, let's say we come back from the database with a movie object that has a title. By default, the title resolver will just be fetching the title field on that object. But typically, we have these sort of nested resolvers that we end up creating. So this example we have here, we have a session field on the query type, and then for the session resolvers, we have a room, theme, and recommended fields on the session. So this comes from a conference application that was intended to be for searching for conference sessions, what room they're in, what are the theme, and then finding recommended conference sessions. And so when a query comes in this case, let's say we are starting from the session field on the query type and we're searching for sessions by some search string. In this case, we're using this sort of ORM-like library. So we're assuming that we have a connection to the database that's stored in the context object. So every resolver is passed a few values here. The first one, this object, oops, zoom in a bit. The first argument object, this is whatever has been resolved so far. So these resolvers are called in a nested fashion. So we start at the session and find the session object, but then we may need to traverse out to, I don't know, recommended sessions, maybe we need to look up the theme for the session. So for the root resolver, this object will be undefined, it'll be blank. But then later on, as we're building up our result set, we'll be passing in whatever we've resolved so far. And then params, these are any field level arguments. And then this context object, this is where we can inject things like database connections. If we've abstracted out the data fetching layer into some API object, we can inject that into the context object. and then reference that in our resolver function. So in this case, we're grabbing a database connection from the context object and then saying find sessions by some search string, where the search string is a parameter to the session field. So that's where we start. And then if we request the room for the session, we need to go back to the database, passing in the ID of the session to find the room. We need to find the theme. We then need to go back to the database to look up the theme given the session ID. If we request recommended fields, we then need to go back to the database to request the recommended sessions. So the point, I guess, the takeaway from looking at this is that we can often end up with multiple round trips to the data layer with this sort of structure of our resolvers, where we know how to look for a session by search string, we know how to find the room for a session given a session ID. And this can be problematic in some cases where we end up making multiple requests to our data layer for any GraphQL request. And many GraphQL requests are very nested with this structure. So that's one thing we want to avoid. The Neo4j GraphQL integrations get around this by generating a single database query at this root resolver level. So we won't be writing any resolvers today, actually. The benefit that we get by using the Neo4j GraphQL integrations is that these resolvers are generated for us in all database data fetching queries are generated for us by the GraphQL integration. And that solves a couple problems that we'll talk about in a second. Okay, so what are the benefits of GraphQL? Why would we use it? Well, the benefits of GraphQL include things like addressing this concept of overfetching. So in our application, if we're rendering maybe a list of blog posts that are written by a certain author, we don't necessarily need to return all of the content for the blog post. We just need maybe the title and an image or something like that to show it. And in GraphQL, because our client can specify only the data that they're interested in for rendering that view, so the client can build a selection set that says only show me the title and preview image for a blog post and give me the list of them. In a REST API, if we ask for a list of blog posts, we might get back all of the blog resource, which might include all of the information we have for a blog object. And that's going to result in fetching more data from the data layer and sending more data back to our client than what we need. And then also it addresses the underfetching problem, where we may need to go in the REST world, we may need to go back and forth to the API to make multiple requests to return the data that we need to render a view. Using this blog post example, maybe we need to show the blog post and the author information. So we want the author name, maybe their brief bio and profile image, and we can construct a GraphQL selection set that says, for every blog post, show me the author and just these fields for the author. Whereas in the REST world, we may get back a list of blog posts, and then for each author in those blog posts, we need to go back to the API and say, okay, give me the details for this author. So addressing underfetching in that way. With GraphQL, we also have a strict specification that is defining exactly what GraphQL is and isn't. In the REST world, we don't really have something similar. We have sort of spectrum of REST-ish to HTTP API, all the way to hypertext as the, I can never remember that one, Hadios or something like that, where we're passing along a hypertext resource that we can then resolve for every resource. So it's not sort of clear what the definition of REST really is. But with GraphQL, we have a clear specification that's telling us that. We can also sort of simplify data fetching in our client application with what I like to think of as component-based data interactions, where we can attach data fetching logic and queries in our components. And we'll see an example of this when we start looking at our React application. Then I think there's also a big benefit of thinking in terms of graphs. So with GraphQL, we have the ability to add different data layers that we are fetching data from in a single API. So GraphQL can be nice for unifying the microservices, but also then focusing our API interactions on relationships instead of resources. Because if we think of our interactions with APIs, it's typically in the context of a relationship. We're interested in who is the author of this blog post and so on, not necessarily discrete resources. Cool, and then this is what I think is really the biggest benefit of GraphQL is developer productivity. And so having a strict type system, so it's very clear what data is available, what data we're working with, what to expect from a GraphQL operation. And we can also introspect GraphQL APIs, which is really nice because then we can sort of treat them as self-documenting. So the documentation that we can generate from an introspection of a GraphQL API, where we say to the API, hey, tell me your schema, tell me all of the types, all the fields that are available. We can generate some nice searchable documentation and tools that we'll play with in a second, like GraphQL Playground and Graphical that embed that functionality, which is really nice. But of course, GraphQL is not this silver bullet that's going to solve all of our problems. There are, of course, some challenges that come up when we start working with GraphQL. So one of those challenges are that a lot of the well understood practices from REST don't really apply in some cases. So for example, HTTP status codes don't really mean the same thing in GraphQL. Typically, a GraphQL request returns a 200 OK response, even if there may be some errors embedded with that, maybe even if we're not authorized for some of those resources. So we may expect a 400 response in the REST world, but we have to think of error handling a bit differently. We have similar challenges with caching. So in the REST world, we can cache REST endpoints, but with GraphQL, because that selection set can be different for any GraphQL request, we have to handle caching a bit differently. Another challenge is, okay, if the client is free to create any selection set, any sort of arbitrary GraphQL query that they want, aren't we exposing some arbitrary complexity to the client? How do we make sure that we have good performance considerations given that? And then we talked about this earlier, this N+1 query problem, where because of the nested structure of GraphQL, we may be sending multiple requests to the data layer, which is going to impact performance. So we'd like to be able to avoid that. How do we rate limit GraphQL APIs? How do we sort of go from the REST world where we can easily say, okay, you can request 10 resources per second, something like that. Well, in GraphQL, if we have a very complex nested operation that's going to be more computationally intensive, we need to have some idea of query costing so that we can use that to apply to rate limiting. So those are some of the challenges that come up. I think tooling and best practices are emerging that address all of these issues. So these are not unsolved or unsolvable problems, just things that we need to be aware of as we're adopting GraphQL. Okay, so that's GraphQL in general. So let me maybe pause there, and if you have any questions or thoughts, drop that into the chat or the QA section in BigMarker. And we'll pause there for a second before talking about now GraphQL in the context of Neo4j. Okay, so I don't see any questions coming in, so we'll move on, but feel free to drop any questions or thoughts you have as we go along. Okay, so this brings us to GraphQL in the context of Neo4j. Okay, question from Oliver. Will you talk about subscriptions? Not in this workshop, no. We will not get to subscriptions. So subscriptions are, sort of like PubSub or event listeners in the context of GraphQL. And they can be useful for, maybe if we're building like a chat application and we want to be notified anytime that a new message comes in. And typically in the Node.js JavaScript ecosystem, these are implemented as WebSocket. But no, unfortunately, we won't get to that today. Maybe we'll put together an advanced version of this where we dig into subscriptions at some point. But yeah, good question. Okay, so we talked about GraphQL in general. How do we use GraphQL with Neo4j? And how do we use these Neo4j GraphQL integrations? So I guess the first thing I want to point out is GraphQL is an API query language, not a database query language. So GraphQL is designed to help you build and query APIs and leaves out a lot of the type of functionality that we would expect from a database query language like SQL or Cypher. So things like projections, things like variable length path traversals that we have in Cypher, these types of things. So when we're talking about Neo4j GraphQL, we're not talking about sort of making the database speak GraphQL. Instead, what we're talking about is really tooling that can address some of the challenges of building an API backed by Neo4j. So at a high level, the goals for a Neo4j GraphQL integration are fundamentally reducing boilerplate. So when we're looking at those resolver functions, there was a lot of boilerplate there of saying, okay, look up this object in the database. Okay, now find this field for this object in the database, essentially for each type in each field. And what we want to focus on with the Neo4j GraphQL integrations is making it easy to quickly get up and running with a GraphQL API. So reducing the amount of code that we have to write, and developer productivity, being able to write less code, get more done, and sort of focus on the more fundamental parts of our application, perhaps. But then also we want to be able to extend any functionality that we generate out of the box. So being able to add custom logic is important. And then also have in mind some of the performance impacts. So making sure that we're not making multiple round trips to the database, that we're not generating these N+1 query problems. So then in more concrete terms, the way that we address those goals is first by supporting, I guess, what's called GraphQL first development. And this is the idea that our GraphQL type definitions can drive the database data model. So what we don't want to do is sort of be maintaining two schemas here, one for our database, one for our API, which then means we need to have this mapping and translation layer between our graph representation in our GraphQL API and our graph representation in the database. So instead, there's a pretty tight mapping from the GraphQL data model to the property graph model that we use with Neo4j. And so what we can do is use the GraphQL type definitions, and again, these are typically written in this schema definition language in GraphQL. Use those to define what the data model should be in Neo4j. And then once we have those GraphQL type definitions, we can then generate a full CRUD GraphQL API. So with all of the operations that we need for create, read, update, delete functionality for all of the types defined in the schema. And then we can also do things like add fields for ordering, pagination, complex filtering, expose any of the date, time, and spatial native types that we have available in the database. You can also expose those in the GraphQL API. The query here, this is just showing an example of some of the filtering functionality that is generated. So with just defining that we have a movie type and how those movie nodes are connected to genres and actors and the fields available, with this generated filter functionality, we can write a GraphQL query that says, in this case, find zombie comedy movies that were released after 1994, or movies that star Jesse Eisenberg and are animated, and then order by release year. So that's pretty powerful functionality for that's generated for us that we can then leverage using GraphQL. Here's where our developer productivity and performance aspects come in. And what we want to do here, so we said that we didn't want to be writing these resolver functions that in our case might have some Cypher queries that define how to fetch data from the database. And instead, what we can do is take a GraphQL request and translate that to Cypher. So that means for any arbitrary GraphQL operation that comes in, our GraphQL integration can translate that to a Cypher query, so we don't need to implement resolver functions, and so that we only need to make one round trip to the database and let the database take care of optimizing with its execution engine that Cypher query to figure out the fastest way to execute that. So this is a really powerful, powerful feature that allows us to get up and running really quickly. And then for extensibility, we've added the ability to attach Cypher queries to your GraphQL schema using the Cypher GraphQL schema directive. So in GraphQL, a schema directive is like an annotation on a field or type that indicates that there's some custom logic that should happen. And in this case, you can think of it as sort of overriding the default behavior of this field, which might be to try to do a simple traversal in the graph or look up the property value on a node. But instead, this then becomes a computed field where we execute the attached Cypher query instead. So this is useful anytime that we have some custom logic that we want to add. In this case, this example, we're doing a sort of collaborative filtering recommendation query in Cypher and attaching that to a recommended field in our GraphQL schema. So this is going to give us recommended businesses given some input. Okay, so those are the goals and the general features of the Neo4j GraphQL implementations. And there are a few versions out there of the Neo4j GraphQL implementations. Neo4j GraphQL JS, which is what we're going to use today. Neo4j GraphQL Java, which is very similar to Neo4j GraphQL JS, but designed for the Java ecosystem. And then the Neo4j GraphQL database plugin, which is a plugin for the database, and the database itself then serves the GraphQL endpoint. You can find the documentation for all of these on the grandstack.io site, grandstack.io/docs, which we looked at earlier. Okay, so let's look at Neo4j GraphQL JS. This is the library that we're going to use in the workshop today to build GraphQL APIs. So again, when we're talking about using GraphQL with Neo4j, we're not necessarily talking about making the database speak GraphQL. Instead, we're very much interested in building this layer, this API layer between the clients and the database. There's functionality that we want in the API layer for implementing things like caching, authorization, custom logic, those sorts of things. So we don't necessarily want the client talking directly to the database. We want to build this API layer. So Neo4j GraphQL JS implements those features that we talked about earlier, where we're using GraphQL type definitions to define the data model in the database, generating resolvers, generating queries, that sort of thing. You can think of the Neo4j GraphQL implementations as having two main pieces of functionality. One is schema augmentation, where we're taking the type definitions and we're adding query and mutation types, we're adding filtering, ordering, arguments, those sorts of things. And then the other main bit of functionality is generating Cypher queries at query time from arbitrary GraphQL requests. We call this GraphQL to Cypher transpilation. And as part of this, also being able to handle the custom logic, so the Cypher queries that we've attached using Cypher schema directives, we want to run those as subqueries in our generated Cypher query. Okay, cool. So that is enough of listening to me chat about the design of the Neo4j GraphQL integrations. Let's actually do something hands-on and take a look at a GraphQL API. So again, if you have any questions or thoughts about what we've talked about so far, GraphQL in general, the Neo4j GraphQL integrations, definitely drop those in the chat or the Q&A section. But I'm going to move on to looking at this GraphQL API. So movies.grandstack.io, if we open that up in the browser, we'll see, you probably won't have this query, that's one I ran earlier. You should see something like this. So this is GraphQL Playground, which is kind of like a query workbench for GraphQL. So by default, when we load a GraphQL endpoint where we've enabled GraphQL Playground, if we load that in the browser, we see this nice UI. And a couple things we can do here. So if we click in the Docs tab, we can start to explore the data that is available in the GraphQL API. So we can see the queries and mutations. And if we had any subscriptions, we'd see that here, but we don't. So these are the entry points for the API. So earlier I was talking about these special, the special query type and the special mutation type. So these are all of the fields that are defined on the query type or the mutation type. And if we click on one of these, we can see, in this case, all of the field arguments. So these are all of the arguments we can pass to the movie field on the query type. And this is saying that then it returns a list of movie objects. And here are all the fields that are available on the movie type. So these are all the fields we can include in our selection set. And we can see how the movie type is connected to other types. So for example, there's an actors field on the movie type that is a list of actor objects. And we can keep traversing to see what fields are available on actor and so on. So this is that sort of self-documenting feature that I mentioned earlier that is the result of introspection. So tools like GraphQL Playground, and later on we'll use the graphical tool, which is very similar. They send an introspection query to the GraphQL API that says, hey, give me all of your types and build this nice searchable Explorer type documentation for us, which is really nice. So we can use that information to start writing some GraphQL queries. So the way GraphQL Playground works is on the left, I can create my GraphQL operations. So we can specify the type of operation. By default, everything is a query, so we don't need to include query. Then an open curly brace, and then one of our entry points. In this case, let's start with movie. And you'll notice that we have autocomplete suggestions here. This is a nice feature in GraphQL tooling as a result of having strict types and this introspection. We can see suggestions. So, okay, we want movie, and then open parenthesis, and we see all of the arguments. Let's say, give me the first 10 movies. And then it's telling us, oh, well, we need a selection of subfields. So you better open another curly brace and give me some nested selection set structure. And again, if we do control space, we can see what fields are available. So let's grab the title and plot of the first 10 movies. And we get back some data. And we can build up more complex traversals. So maybe find me the actor names as well for each of these. And we can build up arbitrarily complex queries. So there's filter functionality. So now let's filter this to, I don't know, where the year is greater than, I don't know, 1994. Let's also return the year so we can make sure that that's true. 94, 95. So let's change this to 96. Cool. So now it doesn't show me Toy Story anymore. We can prettify that. We can also add ordering. So we can say order by year descending. Oh, and I removed first. All right, so now this says, find the first 10 movies where the release year is greater than 1996, ordered by year descending, and give me these fields. Right, so you can see how we can start to build up arbitrarily complex GraphQL operations. Okay, cool. So let's take a few minutes and see if we can answer these questions. So For our first hands-on exercise, we'll want to open up the movies.grandstack.io GraphQL playground and take a look at the documentation and the schema tab to see what data is available, what filtering functionality we have to answer these questions. Find titles of the first 10 movies ordered by title. Who acted in the movie Jurassic Park? What are the genres of Jurassic Park? What other movies are in those genres? And what movie has the highest IMDb rating? When you're looking for some hints on the filtering functionality, it might be helpful to look in the GRANDstack documentation, specifically in this GraphQL filtering section, might be helpful. Okay, so let's pause here. I'll put 15 minutes on the timer. So we'll count that down. And go ahead and work through that. And we will pick back up to go through these. Looks like at 9:16 my time, so in about 15 minutes. So if you want to take a little break, you can do that as well, and then we'll review the answers here. And if you have any questions, if you run into any issues, just drop a note in the chat. And I'm gonna step away for just a second. Okay, so we have just a few seconds left. So we're going to find out what noise this timer app makes. I haven't used it before. Kind of scared of what the alarm is going to be. We'll find out. Okay, that wasn't too bad. Okay, so time's up on the exercises. Sounds like a few folks got all of the answers. Cool. I just shared a new poll asking what graph apps for Neo4j desktop you've used. I guess I should have had an option on there for none, but I'm curious what graph apps folks like, what they're using. It wouldn't let me add all of them on there, so if I missed one, chime in on the chat on what graph apps you're using. But anyway, that's the next section that we're going to look at. So we'll take a look at that in a minute. Okay, so let's take a look at our exercise answers. I guess maybe we'll do an ask the audience here. Does anyone want to share the query for this first one? Find the titles of the first 10 movies ordered by title. If you got this one and you want to share your answer, try to drop it in the chat. We'll see how good Big Marker Chat can handle code. Okay, we got one from Lewis here. Let's see if we can do a copy paste prettify. Okay, so the first question is find the titles of the first 10 movies ordered by title. Oh yeah, posted a different one. Got it. Let me grab that one. So from Lewis, oops, in between the curly braces. So one thing I really like about GraphQL Playground and graphical that we'll use in a second is this prettify functionality. So however we paste it in, we can hit that and get nice formatting. Okay, so the question was, find the titles of the first 10 movies ordered by title. Here's what Lewis sent us. Let's see if that gets us the right results. Yeah, so we're starting with the movie query field, order by title, ascending, first 10, turning the title field. And you can see here, yeah, we have some non-alphanumeric characters. So when we do title ascending, we get those first. So we have one that includes a double quote, $, single quote, and so on. So we get those first. We can also do title descending. And we get kind of a similar thing on the other end of the spectrum here, where we have some special characters with accents as well. Okay, cool, great. So thanks, Lewis, for that one. The second one, who acted in the movie Jurassic Park? Does anyone want to share that one? From John, let's take a look at this one. And we'll hit prettify, there we go. Okay, so movie title Jurassic Park, actors name, let's give that a run. Cool, Jeff Goldblum, Laura Dern, Richard Attenborough, and Sam Neill. Cool. Another way to do this, so if you notice that the query field arguments are for an exact match, so we could also do something like here where we're using the filter functionality, and we can say like title contains Jurassic, if we're too lazy to type Jurassic Park. Then of course we get back, to add title to this, we get back Jurassic Park 3, Jurassic World, Lost World, Jurassic Park, and so on. But yeah, we could also say title contains Jurassic Park, or even an exact match using the filtering for title. Cool, great. Thanks, John. Okay, number 3, what are the genres of Jurassic Park, and what other movies are in those genres? Someone want to share their solution to that one? I guess Lewis already sent us that one. At least I think it is. Let's take a look. So this is the first query that Lewis sent us. Let's give that a run. So movie title, Jurassic Park, actors, and then genres. Give us the name of the genres, and then for each of those genres, traverse out to find movies for those genres. And we're probably going to get back a lot of data here. You can see we just get back this massive list of movie titles. What genre is this for? Thriller. So we have a ton of thriller movies. So maybe we could do something like look at, I don't know, maybe the first 10 in each genre, order by year released. Give me the most recent movies in that genre first. So whatever data set this is, the most recent thriller that it has, descending, not ascending, for most recent. So most recent movie in the thriller genre is Hush, sci-fi, Kill Command, adventure, so on. Cool. Okay, so thanks, Louise, for that one. And the final one, what movie has the highest IMDb rating? Did anyone get this one and want to share it in the chat? Okay, Robert shared a query. Let's take a look at that. So paste that in, hit prettify, give it a run. Okay, so movie, first one, order by IMDb rating descending, and we get the wedding gift. Let's include the IMDb rating. And you can see that we have a null for this. When we look at maybe the first 10, we have some nulls. So we're missing IMDb rating for some movies here. Right, and so what Robert says, how do you filter the nulls out? So yeah, so probably what we want here, you know, if we're in some movie search application, we don't want to show these movies that are missing the IMDb rating. If the user asks to order by those in descending, they want to see what are the highest rated movies, not where the rating is missing. Yeah, so how do we filter the nulls out here? Did anyone get that? Being able to filter out the nulls? So this is a bit of a trick question, I guess, since we're asking not just for the ordering, but also being able to filter out the null IMDb rating values. Well, if we look at our filter argument, so let's make some space here. And if we add a filter argument, and we know we want to filter something regarding IMDb ratings, let's see what suggestions we have. So IMDb rating, exact match, in, less than, greater than, not, less than or equal to, greater than or equal to, not in. So I think we can do not null. Oh, missing a comma there. Okay, so yeah, so if we say filter where IMDb rating is not null, then order by rating descending. Give me the first 10. Cool, and the first one is Band of Brothers with an IMDb rating of 9.6. Cool, looks like John sent us that answer also. Cool. Yeah, so that's a bit of a trick one with the idea, get us to look at some of this filtering functionality. And there's a couple of ways to figure out what's the syntax for that filter. We can either try to do the auto completion in GraphQL Playground. We can look at the docs tab. If we look at this movie filter, so you have a movie filter input. So if we go here down to movie filter, we can see like, okay, we can do filtering on all these different fields, and depending on what type it is, we get different arguments, right? So IMDb rating is a float, so we get like greater than, less than. Poster, which is the poster URL, is a string, so we get things like contains, starts with, and so on. The nulls are a bit tricky because that there isn't really a clear example that we can use a null there. If we look in the documentation, this walks us through some examples as well. And then finally, we have, I think, somewhere, yeah, this big chart that shows us the different options we have. I like this documentation page quite a bit because it embeds these graphical examples. So we can run in the documentation some of the examples, and we can, this is live, we can modify this. So return title, year, poster URL as well. I think that's fun in the documentation. Another feature I like in the documentation, at the bottom of every one of these, there is this, was this content helpful widget. So if you have any thoughts on the documentation or feedback, you can click yes or no and send us little notes about what would be helpful to include in the docs. So I'd encourage you to send any feedback for these docs pages if you have it. Okay, so that was the last question in the exercise. Great job, everyone. Thanks for sending your answers in. Let's move on since we're...
Well, before we move on, Luis had a question in the Q&A. He said, I noticed when running all the queries at the same time with aliases, the order by filter is ignored. Could this be a bug?
It could be. Let's take a look at that. So you're saying at the same time with aliases, so that would be, you mean something like this, where you're saying this is, do you mean with a named operation like this, where I'm saying this is query Q1, or do you mean aliasing the fields like this? So if I say alias title to name, order by title descending, saying that it ignores title, maybe? Yeah.
He pasted something in the chat.
Okay, let's take a look. Oh, I see. So aliasing each query. Gotcha. So alias this JR. Here's one we're ordering best movie. Order by IMDb rating descending. Give me the first one. So let's look at that one. So that gives me Toy Story, which if we return the IMDb rating, maybe doesn't actually have the highest IMDb rating. Yeah, 8.3. Yeah, that's a good observation. Yeah, so this best movie, IMDb rating of 8.3, that's not correct, right? That should be Band of Brothers or one of the null fields. So yeah, that's a good observation. Not sure what's going on there. Yeah, I think that's a bug. If you wouldn't mind submitting a GitHub issue for us in the Neo4j GraphQL.js, I'll drop the link to the issues GitHub. Yeah, that looks like you found a bug there. So thanks for pointing that out. Cool. Any other questions or thoughts before we move on? Okay. So in the next section, we are going to now take a look at using GraphQL with Neo4j. So this movies endpoint that we're using, this is just some demo GraphQL API to us. We haven't looked at the code for how this works under the hood. Under the hood, it does use Neo4j GraphQL.js to query a Neo4j Aura instance that has the movies dataset. The dataset that's using is the same as what's in the recommendations sandbox in Neo4j Sandbox, if you're curious. But what we want to do now is take a look at how do we actually build GraphQL APIs using this Neo4j GraphQL integration that we talked about. And one way to do that is using this GraphQL Architect Graph App for Neo4j Desktop. Here's kind of a screenshot of a specific view of it, just to give you an idea. This is where it embeds graphical that allows us to query using graphical, which again is very similar to GraphQL Playground. It's just easier to embed in applications, which is why we're using graphical. So there's a blog post that is linked here that talks a bit about what GraphQL Architect is, some of the features. There's a video walkthrough of it as well. And basically the idea here is to have all of these sort of low-code tools in one place for doing things like querying a GraphQL API, running a GraphQL API locally, where we're just specifying some GraphQL type definitions and a Neo4j database to connect to. It also has this really neat functionality of inferring the GraphQL schema from an existing database. So we talked about the case where we're defining our GraphQL type definitions and using that to define the data model in Neo4j. We can go the other way initially too. If we have an existing Neo4j database and we want to build a GraphQL API exposing that data, we can inspect the data in the database, generate those type definitions, and then get a GraphQL API with basically just one click of a button. And then we want to be able to add custom logic using this Cypher directive. And then we have a type definition editor that's going to give us schema-aware hinting. We've seen how useful that sort of schema-aware hinting is when we're writing queries in GraphQL Playground. So we want to have that same functionality in our editor as we're editing this GraphQL SDL. Okay, so this is a good resource. I won't go through the whole blog post. We'll talk about some of these things now. But first, what we want to do is get this installed. So GraphQL Architect is a graph app for Neo4j Desktop. So that means that we are going to install this into Neo4j Desktop. So hopefully everyone has Neo4j Desktop installed. And if not, you can get it neo4j.com/download. You can go here to download it real quick. So what we'll do is open up Neo4j Desktop and open the Graph Apps gallery. So there's this Graph Apps drawer slide out icon on the left that will then show you all the Graph Apps that you have installed. If you click on the Graph Apps gallery, it will open up a graph app for installing graph apps, I guess is a good way to describe what it is. So it shows us all the graph apps that we can install with one click. GraphQL Architect should be on there somewhere. Just click the install button and that will add it in desktop. If you're using Linux, I think this deep linking functionality doesn't work in Linux, or I'm not sure if that's been fixed yet. But in that case, you'll want to copy this link and paste that in to the install form field in desktop. I'll show where that is in a second. And then once you have installed GraphQL Architect, to open it, you can either click on it in this Graph Apps drawer, the icon here, or for any running database, you can click this open dropdown and select it in your list of graph apps that you have installed. And then you should see a screen like this. When you first launch it, we'll talk about what's going on here in a second, but that's the installation. We can also go, I guess the easy shortcut way is to go to install.graphapp.io and click it here, which will deep link into desktop as well. But I like to use the Graph Apps gallery since that's already built in to desktop. Okay, so let's drag down desktop. So here's Neo4j desktop. And if I click here on Graph Apps gallery, open a new window, and then I can click here to install it. I get an error because I've already installed it, but you should see something that says it's installed. Again, if you're on Linux, what you'll want to do is copy this. Oops, yeah, copy this URL. So instead of clicking, you can do a right click, copy, and then down here in the install. So again, this is the Graph Apps slide out. In this install form field, paste that. And this is just pointing to GraphQL Architect on the NPM registry. So just desktop just installs the latest release from NPM and click install. To do it that way, if you're on Linux, I think is the best way to do that. And then we have a database running. So in desktop, currently we can have only one activated database at a time, and GraphQL Architect will connect to whatever my activated database is. So in this case, I have a local database. Now I can open up GraphQL Architect. Oh, opened up here. Cool. And it starts, and I see something like this. Okay, so the next exercise is to do a couple of things. So what we're going to do is launch a Neo4j sandbox. So if you haven't used Neo4j sandbox before, this is a great way to spin up Neo4j instances that are hosted for you for free in the cloud. They only stick around for 3 days. You can extend it to a week. But it's a great way to play around with Neo4j data sets, especially if we want to deploy our application, which is what we're going to do later on. So that's why we're using a sandbox instance and not just a local Neo4j database, because we want some database hosted in the cloud, because when we deploy our GRANDstack application, we need a database in the cloud for it to talk to. So we want to launch a blank sandbox. And then this will take a minute to spin up. So if you haven't used Sandbox before, you may need to sign in. You can sign in with like GitHub or Google or Twitter, or create a new username and password authentication for Sandbox. The reason that you have to sign in is because these Sandbox instances are private to you. So you'll get the login credentials for your Sandbox. And the idea is only you should have access to these. Okay, so I'm going to open Neo4j browser for my Sandbox instance. Neo4j browser, which I think all of us have probably used and are probably familiar with, but if you're not, it's a way for us to execute Cypher queries against Neo4j, in this case, our Sandbox instance. And what I want to do is run :play GRANDstack. So this is going to load a browser guide that embeds, in this case, a Cypher query that we're interested in that's going to load some sample data. So this is going to do a load CSV and then create some business user review data. So just click on this, click run, and we'll add just a small data set to Neo4j Sandbox. Okay, so that's the first part of the exercise. I'll go through the next part in a second, but basically what we want to do now is log into Neo4j Sandbox, create a new blank project, launch Neo4j browser with that, do that :play command, click that embedded query, and then connect it to Neo4j desktop by creating a new remote graph. Then install and launch GraphQL Architect, which we took a look at it at how to do that in the Graph Apps gallery. And then start a local GraphQL server. So once you start GraphQL Architect, you'll see a button for starting a local GraphQL server. And then take a look at Graphical. So Graphical is going to be, do you still have it open? No, we closed it. Graphical is going to be in this pane behind the editor for GraphQL Architect. So the first thing I'll see up front are my GraphQL type definition editor, and I can resize this, and I can, I can get full width view with the slide out. I can go into dark mode and whatnot. So some options there. But then behind the scenes here is Graphical, which is just like GraphQL Playground, but a bit different. It has a bit different look, especially around the documentation view. So I can resize this, or I can toggle off that editor as well. Okay, so play around with the graphical pane in GraphQL Architect and see if you can execute a GraphQL query to find all businesses and any reviews for the business in this sample data set that we loaded. Okay, so let's take another 15 minutes or so on the timer to work through that. If you run into any issues while you're doing this, if you can't get desktop downloaded, if Sandbox has some issues, definitely just let us know in the chat. And let us know when you get through all these steps, and then we will pick up from there in about 14 minutes. Okay, I don't see anyone they're having any issues, so maybe I'll go ahead and work through the next couple of steps here. Let's see, so I created my blank Sandbox instance. I ran the :play GRANDstack query to load some data, and it says I loaded 36 nodes, set some properties, created some relationships. If I do a call db.schema.visualization, I can take a look at the data model here. So this says we have some business nodes. So businesses are in a category. We have some user nodes. Users wrote review, and review is connected to a business. If I just look at some of these businesses, here's what we have. We have This must be the Neo4j office business. We have an address, city, point type, location. We traverse out. It's in the category of graph database. Looks like it has one review. Here's our review node. So reviews, looks like we have an ID, a star. So that's like the rating for the review, and then some text, world's leading graph database HQ. And if we traverse out, it's written by the user Will, and can traverse out to the other reviews that Will has written. By the way, in Neo4j browser, if you ever get these seemingly unstyled nodes, this will happen sometimes after you run the call db.schema query. What's going on here, there's some configuration for what property you want to use for the caption. So I can click on the label up here, and then I can select what property to use for that caption. So for the review, I don't know, maybe I want stars, date, text. And if your styling ever gets really bad, you can do a :style reset, and that will reset the configuration for the styling of the visualization. Anyway, so okay, so that's the data set we have. So we have some sample data for businesses and reviews, categories, users. Cool. Okay, so now I'm going to connect this sandbox instance to Neo4j desktop by creating a new remote graph. Okay, what does that mean? So let's switch back to Neo4j desktop. So in Neo4j desktop, and I'll close the Graph Apps slide out, and this is the one that we probably typically see, which is this projects tab. So I can have projects. Each project can have multiple databases. Here I'm in Fullstack GraphQL project. And when I go to create a database, I can either create a local database or a remote database. So if I create a local database, I can choose what version it is. I can download it and manage it and operate it locally. But what's nice about desktop, and this is especially nice for using graph apps, is I can connect remote databases. So if I have a self-hosted Neo4j database and I don't know, on AWS or something, I can connect to it in desktop and then use all of the desktop tooling, including graph apps, to interact with it. Sandbox works this way. Neo4j Aura as well. I can connect in desktop. So what I want to do is connect to a remote DBMS and put in the connection credentials. So if I go to my sandbox instance, go to the connection details tab, I have the Bolt URL, I have a username and password. But there's this new feature as well, where I can just click this button, add to Neo4j desktop project, and that will deep link into Neo4j desktop. So I'll say, yep, open Neo4j desktop. And now I get to choose what project to add it to. Let's add it to Fullstack GraphQL. And this should create a new database. Oh, maybe that didn't work because I had the add database modal open. Maybe we found another bug there. Let's try that again. So connect, open desktop, Fullstack GraphQL. There we go. Now it's populated. So sandbox, data expires, Bolt URL. I want to use username and password, and it has my username and password already populated from here in my okay, time's up. I don't know if, I guess you guys probably can't hear that. It's very loud in the headphones, very startling. Okay, yeah, so that automatically populates the connection details And I can then click connect to set this remote database as the active database for desktop. Cool. So if that add to Neo4j desktop button didn't work for you, okay, I think that deep linking functionality doesn't work on Linux, but I might be wrong. What you'll want to do is add database, connect to remote. We'll call this blank sandbox. Copy the bolt URL. There's two bolt URLs here. One is the bolt URL, and then one is a WebSocket bolt URL. And the difference is if we're using the browser JavaScript driver, that uses WebSockets. So say if we're like connecting directly from, I don't know, maybe like a React application or something like that directly to Neo4j, and we want to use the secure WebSocket specifically, we can use this one. Otherwise, in most cases, we want just this bolt URL. Username and password. The username is Neo4j and whatever random password you have. And then sandbox does not use an encrypted connection on that bolt URL. Okay, so if that deep linking into desktop to add the remote graph didn't work, that's how we do that part. Okay, and then the next one, install and launch the GraphQL Architect Graph app. We talked about how to install it. I already have it installed, so I'm going to click this drop down and select GraphQL Architect. Opens a new window. Cool. So the first time that we, can I zoom in a bit? Yeah, maybe that's a bit more readable for you. So the first time that I launch GraphQL Architect, it connects to whatever active Neo4j instance I have active in desktop. And in that case, it's my sandbox instance with that business reviews data set. And then it says initializing your Neo4j schema. It's going to take a few moments depending on the size of your DB. Received type defs in first schema done. So what's going on there is GraphQL Architect is inspecting the data that we have in Neo4j, inspecting the data model and generating the GraphQL type definitions to match that data in Neo4j. And then it populates over here. This is the GraphQL type definition editor, populates that with the generated GraphQL type definitions. So now what I can do is, without editing those, I can click Start, and this will switch to now local GraphQL server running, localhost port 4000, GraphQL API ready. And I can either slide this down or toggle this off to go now to graphical. And I see some errors in here. This is a previous query that I was running. But now if I go to the Documentation Explorer and take a look, I see that I have user review, category, business, and so on to query this data set. So I can do a query like business, show me all the businesses, and so we're interested in what in the reviews, and the review has stars and text. Okay, so here's basically the whole data set, at least the businesses that we have and any reviews for each. And here's that Neo4j example that we saw in the browser. Cool. So we're querying our Neo4j sandbox instance using GraphQL and we didn't have to write any code. All we did was click a couple of buttons and we had a GraphQL API up and running, which is pretty nice. Okay, did we do all of this? So we started the local server, we navigated to graphical, took a look at the docs tab, and we ran a query to find all businesses and any reviews for each business. Yep, we did that. Neat. Okay, did everyone make it through that? Did anyone have any issues getting GraphQL Architect running? If you ran into anything, let us know in the chat. In the meantime, I want to take a look at the poll result here to see what are the most popular graph apps. So it looks like it's a tie between the Neo4j ETL tool and the APOC user guide. And then we have the graph apps gallery after that, Neuler, which is the graph data science playground, GraphXR, Halen, semantics is on there as well. Cool. Yeah, so it looks like folks have used a few of the graph apps. I would encourage you to play around with those if you haven't. There's some really neat functionality in there. So the ETL tool for loading data from relational databases, Halen for monitoring our Neo4j cluster. The Graph Data Science Playground allows us to use this Graph Data Science library without writing any code to construct queries to run algorithms like PageRank, community detection, and so on. So, and then if you're using spatial data, you can definitely check out the Neo map visualizer for visualizing spatial data as well. Cool. Maybe we'll take a slight detour here, since I did notice that we do have some spatial data in this data set. Let's take a slight detour just so we can see what sort of businesses we're talking about. If I switch to NeoMap, NeoMap allows us to create layers. So I promise this will be a quick diversion, but just to give us a better understanding of where these businesses are that we're talking about. So we can choose the layer type, which in our case, we have point geometries on business nodes. They're stored the location property, and for the tooltip, let's select the name for max nodes, and we only have like 40 as markers. Let's add those to the map. And we can see that there are basically two areas that we have these businesses that we're interested in. We have some in California, the Bay Area. So here's Neo4j HQ. Here's a car wash. Here's Hanabi, famous ramen restaurant. And then we have some other businesses over here in Montana as well. So anyway, if you're curious, that's where those businesses are that we're talking about. So anyway, those are the type of things you can do with graph apps. A lot of this, sort of low-code functionality that helps us do more advanced things with Neo4j. Okay, cool. So from the chat, I forgot to hit infer schema, but now it's fine. Okay, cool. Great, so that was the exercise. What we want to do next is take a look at how we are sort of generating this schema from our GraphQL type definitions. So basically what we want to do is talk a little bit and look at how that schema augmentation process looks. So when we go from type definitions as the only thing sort of driving the functionality of our GraphQL integration, looking at what we get out of that. And so far we've seen the query field arguments, so how we can search for exact matches. We saw a little bit of the filter functionality, but maybe let's talk a bit about this concept of relationship fields and mutations. And since the next exercise is going to be writing some mutations, let's talk about that a little bit. So I'm going to switch back to GraphQL Architect. And if I take a look here at these type definitions that have been added, so the first thing here, and you see these green things, these are comments. Comments are perfectly valid in GraphQL SDL. But we have a few declarations here for some custom scalars. So in Neo4j, we have a point type, a date type, and a date time. So these are just some of the temporal properties that are available in the database that are also available in the Neo4j GraphQL integrations. And then we also have a long type, so 64-bit integer that GraphQL itself does not include. So we add that as well, so we can work with those in the database. Okay, so you'll notice here that there's kind of this one-to-one mapping in the GraphQL type system to the property graph model. So we have a user node label in the database, and we have a user type. We have a name and user ID property on this user type because we have name and user ID properties on those nodes in the database. What we don't have are these relationship types. Actually, what we haven't talked about yet are these relationship types. So here we have this rote relationship that is connecting a user to one or more review objects. Okay, so we saw this sort of syntax in the GraphQL SDL examples we were looking at before. So we said this is sort of how we're defining the graph in GraphQL. So that's how these entities are connected. But one thing that we don't have in the GraphQL data model that we do in the labeled property graph model that we use with Neo4j is that every relationship has a direction and a type. So to capture that information, there's another directive that we use in the Neo4j GraphQL integrations called the relation directive. That is sort of adding metadata for how we want to map this relationship field to the database. So in this case, name, this is referring to the relationship type. So the reason we don't just map the GraphQL field name to the relationship type is that there are slightly different conventions there. So in the labeled property graph, the convention is all uppercase with underscores. And typically in GraphQL, we use lower camel case. And so in order to be able to have conventions in either of those systems, we have this name argument where we can have, and if we want, we could have a completely different name. So this could be something, I don't know, like written by or something if the direction was the other way. And the other thing we have is a direction. So there's an enum here. Actually, can we get our, yeah, there we go. We can get our schema-aware syntax suggestions with control space. So one thing that's nice about this GraphQL SDL editor is that we have these schema-aware hinting with tab completion. So it knows that direction argument in the relation directive takes a relation directions enum, and valid values are in or out, which is nice. Cool. So that's how we define relationship fields, and how we're able to map that specific metadata of a relationship direction and type from the label property graph to GraphQL when we don't necessarily have that in the GraphQL model. Other than that, I think there's a pretty tight one-to-one mapping from the property graph model to the GraphQL data model. Oh, the other thing we add here through the inference comes from the infer schema process, but this is also added when we use the Neo4j graphical integration, is this underscore ID field. And this field is the internal node ID in Neo4j. So this is not like a GUID or something like that we want to use in an external system. It's just basically mapping to an offset on disk somewhere that represents the internal node ID for that node. Something that's just added during the augmentation process to expose that as well. So those sort of private things are namespaced with that underscore. Okay, let's talk about mutations. So far we've looked at the query API that's generated given some type definitions, but we haven't talked about mutations. So if we look in the mutations tab in graphical, we can see that there are quite a few mutations that are generated here. And basically there's a mutation generated for every create, update, and delete operation for all of the nodes, so for all of the types that we defined. But then also, and then also a merge, which maps to the merge syntax in Cypher that you may be familiar with. And then we also need to have mutation operations for relationships. So for that, we use the convention of add and remove. So for example, to create a user wrote review relationship, we add a add user wrote. And these mutations take an input type. So here there's a user input type is the argument for the from, and a review input is the argument for the to. So this is sort of creating a relationship from a user to a review. So we look at the input, that is a string in this case, which is the name of the user. So why is it the name of the user? Well, there's sort of a convention that we use for figuring out what the ID, or you can think of it as the primary key for a node should be. And we use that primary key field in the input types for the mutations to refer to those nodes, especially when we're creating a relationship. So we want to create a relationship from one node to another. We need to know what is the ID of each of those nodes. And there's a convention that we use. I mean, ideally, if we were writing these GraphQL type definitions ourselves, we would declare that this user ID is of type ID. And let's do this for the review ID. Category, we just have a name. So category we'll leave, and business has a business ID. So we'll change that to type ID. Oh, and these exclamations, this just means that field is required. So if we're creating that data, we need to specify a value for that field. That means it is non-nullable. if we leave that off. So for example, on the review, there's a text field that does not have this exclamation mark. And that means that this is an optional. This is a nullable field. So we can have reviews. They have to have a stars, the value for the stars field, but they can leave the text field blank. That's acceptable. Okay, so what's the point of changing this to ID? Well, in GraphQL, there is a type of ID, and that basically is saying that this is a unique ID for this type, and that's exactly what these fields are. So we want to indicate that so that our schema augmentation process picks that up and says, okay, when you're referring to a user in the user input type for GraphQL, please use the user ID field, don't use the name field. The reason it had selected name was because we hadn't specified which one was the ID, so it just took the first non-nullable string property. There's sort of an algorithm there that it chooses. So if we toggle back on the sidebar menu, and if we restart our GraphQL API, and now if we switch back to the editor, look at the mutation, and now if we look at the user input type, now the user input type is using the user ID field because we specified type ID. We can also use directives to override this. So if we take a look at the GRANDstack documentation, let's search for schema directives. We can also add this ID directive that overrides this logic of this is the ID field and specify that explicitly. We can also indicate which fields should have uniqueness constraints or indexes created through this schema assert functionality, which is quite nice. Okay, so that's a quick look at the mutations. Let's see how we actually use these. So let's say I wanted to create a maybe a new user. So we need to specify the type of the operation. So previously we were just running queries, so we could get away with not specifying query here, but in this case we want to say mutation. And then let's run create user, and we'll now see the arguments. So we need to add a name. Let's create a user for Adam. And if we look at the control space, if we look at the tab completion here, we can see that name is required, that's non-nullable, and then there's this user ID field. Well, here, let's look at the docs tab to see what type that is. So create user is of type ID, but it's nullable. So even though in our type definitions, user ID is non-nullable, so this is saying that we can create a user without giving them a user ID. That seems to not be correct according to our GraphQL schema and our types. Well, the reason for that is another feature of this library is anytime that we have an ID field in a create mutation, we don't maybe want to necessarily specify what the ID for that field is from the client. Maybe we want the database or the API to generate that. So if we can leave off those ID fields, and then those are generated using a UUID function in the database. So let's return the name, and user ID for this node that we create. It says, hey, you created a node Adam with this value for user ID. And if we switch to Neo4j browser, let's look for a user where name is Adam. Yep, there he is. That's user ID. He's not connected to anything yet. Okay, so that's a look at the mutation API. There's more examples in the documentation, in the schema generation and augmentation, in the generated mutations. So let me link that here in the chat. That is, has some better examples for the mutations that are generated. Okay, so let's take some time for an exercise or a quick break. So the next exercise is to write some GraphQL mutations. So we're going to do this in GraphQL Playground, not GraphQL Playground, GraphQL Architect rather, sorry, in Neo4j Desktop, using the schema that we generated from that sandbox instance with our sample data. Be sure that you change the ID fields from string to ID, because that will make a difference in these mutations. What we want to do is write some GraphQL mutations to do a few things. One, create a new business node, make up a fake business or use your favorite cookie store or whatever, and then connect this new business to a category node and add a review. So create a new business, connect it to a category, add a review. So we'll figure out how to write those mutations. Let's put 10 minutes on the clock here. Where did my timer go? There it is, 10 minutes. Okay, so let's see if we can write those mutations. If you get stuck with anything, let us know in the chat. And if you get done with this, also let us know so we can make sure everyone is getting along. If you take a break, take a short break, and we'll start up again in about 10 minutes. So one thing that I'll just mention as you're going through this to think about, be sure to take a look at what fields are required in these mutations. So for example, if we take a look at the create business mutation, here, create business. The only nullable field is business ID. So we need to make sure that we specify a value for address, city, name, location. And for location, that is a Neo4j point type. And This one, the input type for this one is a bit interesting because the Neo4j point type is flexible enough that it can be 2D or 3D. And we can also specify different coordinate reference systems. By default, we're assuming geographic reference system, so latitude and longitude. So while you can specify 3D XYZ on a Cartesian coordinate system for a business, that's probably not what we want. So latitude and longitude are probably what we want to use here for that input type. So just something to think about there. John says having trouble getting to a business input type. Is that, John, is that for creating a relationship then? So connecting the business to a category? Yeah, for add business and category. Okay, yeah, we'll take a look at that in a second. John, are you getting an error? Or is it a matter of having the wrong syntax there? Yeah. Yeah. So try. You know, one thing that's helpful is try to take advantage of that autocomplete. So control space will give you the syntax aware hinting oftentimes. So that can be helpful to try that, or to check in the documentation for what fields are expected. But yeah, we'll take a look at the solution here in 10 seconds, I guess. Okay, cool. So time's up. Pencils down, I guess. So let's see how we did. So for number one, create a new business node. Does anyone want to share what they came up with here for creating a new business node? If not, then I will add the Central Park giraffe node to our graph. Okay, so I'm not seeing anyone sharing their mutation for creating a business. So let's just go ahead and add one. Oh, here we go. Here's one in Ottawa. Thank you for sharing that. Let's just copy that and drop it in and prettify it. Okay, so create business. So we're setting in a business ID, business ABC with some fake address and state in Ottawa, latitude and longitude. Cool. Let's run that. Great. So we've created this business. Let's also return the business ID. So we have that. Well, I guess we don't want to run it again. We don't want to create a duplicate. So business ID is 11. We'll just have to remember that. Okay, cool. Thanks for sharing that. If we switch to Neo4j browser and take a look at a business with business ID 11, return business, there it is. No relationships yet. Let's solve that. So the next one is connect this new business to a category node. Does anyone have the solution for that one that they'd like to share? Well, the first thing we can do is take a look at what categories we have. And let's decide what category we want to put our business in. Okay, so I see one, so I have this, but it does not work. And that's the business we were using before. Okay, cool. Let's start with that because yeah, that's a good one. Cool. So copy this. I'm just going to add in a couple of things here so that let's not worry about prettifying this. Let's just do that ourselves here. So this will be our selection set. Okay, cool. So merge category business. Okay, so this will work. So this is it's going to do a merge operation. So for the relationships, we said that we have add, remove, and merge. So merge is useful. We want to make sure we don't create duplicates. So if we look at this, we are saying merge from, in this case, from the business to the category. If we take a look in the docs, so this is a business input. And we see it takes a business ID. So I think the reason this may not have been working is we're trying to use the address field to refer to the business. So we use, for those input types that are generated, they are specific to that primary key field again. So that's where the importance of that comes in with specifying the ID type. So here in this case for the business, the ID type for the business. If you didn't change that to an ID type, it may have picked address. So you may have address as the proper ID fields. But in my case, I changed that to of type ID, so it wants the business ID, which I think we said was 11. Okay, and then this one, this is going to be a category input, which this should be fine. We have a category beer, that should be good. And then our selection set, we have a from field. So it's going to be from the business to the category, which has a name. So something like that. Let's see if that works. Cool, yeah, so it says we've now added this relationship, which we did via merge from ABC to the beer category. If we now go back to Neo4j browser and expand out, we can say, yep, cool, ABC business is now in category beer. Great. So the next one, add a review for this business. Did anyone get this part working? Does anyone have a create review mutation they'd like to share? Or I guess you do a merge, that would work too. But does anyone have one they want to share? Otherwise, I'll make one up. Okay, well, the first thing we're going to want to do is create a review. And a review is going to take a date input. So year, month, day. Review ID, we can see is nullable. So I can tell that because this is not a required field. So we can leave that blank, it'll generate one for us. And then review must have a stars. So this ABC beer business, let's give it 5 stars. Text is optional, but let's go ahead and give it some text. And then let's return the review ID, since we'll need to use that in the next operation to connect it to the business. And then I want to show how we use this Neo4j date. So date is an object field, and we can do anything. We can select any of the subfields of the date components. So if we're using a date time, we would also have like minute, hour, second, and so on. But for date, we just have year, month, date, or we can just select the formatted representation. Cool, so let's create this. It says, yep, you've created a node, gave it this ID. So let's copy that, because then the next operation we want to do is add business reviews. And this is going to be from, so the review input is this review ID, and 2 is going to be the business input. We said that the business ID was 11. And then again, we have a from, which is the text or the review. So we'll say give me the text of the review, and 2, which is the business, give me the name of the business. So this will create a relationship connecting the review that we just created to the business, which we can verify a couple of ways. One, if we write a query that says, show me businesses where the name is ABC, show me the name, location, make sure we got all these right, any reviews of the business, text, and stars. Show me all this information. Yep, looks like we found it. We can also verify that by switching to Neo4j browser. Here's ABC. Now if we traverse out, here's that review node. Okay, cool. So that is a look at the mutation API that is generated for us. I guess the takeaway there is that there's a lot of individual operations that are generated for those GraphQL mutations. So we can create nodes, update nodes, merge nodes, and so on. But we end up doing these very discrete operations to do that. Wouldn't it be nice if we could write some more custom logic? Let's say we had a mutation that we wanted to do where we created a review, created a business, connected the business and the review and the user all in one operation. That would be nice. Or if we had some other custom logic that we wanted to add, maybe like generating personalized recommendations for users and businesses. And so that is where my favorite feature of the Neo4j GraphQL integrations comes in, which is the Cypher schema directive. So far in this GraphQL API, we've been working with just the generated CRUD API. We haven't added any custom logic, but we can add these Cypher directive fields now to add basically any custom logic that we can define with Cypher. And as you know, Cypher is very powerful, especially with the use of procedures. So we can make 8 calls to APOC. We can use Graph Data Science library procedure calls. We can even write custom procedures, install them in the database, and call them from these Cypher directive fields. We can pass arguments into these, and in the authorization section, we can even pull in authorization tokens into these queries. So this, I think, is the most interesting and the most powerful feature in the Neo4j GraphQL integrations is this Cypher schema directive. So what does this look like? Well, what this means is we can add fields, or in this example here, we're extending the type. So GraphQL has this extend keyword where maybe somewhere in our type definitions, we have the type definition of business, and then somewhere else later on, we want to extend it by adding types. We can do that. So here we're saying extend the type business to add the field average reviews, which is going to be a float. And the logic for that field is defined by this Cypher query. So the, oops, zoomed in a little bit. So the Cypher schema directive is this annotation that says, hey, there's some custom logic going on with this field. And then here's the Cypher statement I want you to run. So in this case, it's running a match where this, so what is this? Well, this refers to, it's a special keyword in the case of these, I shouldn't say keyword, it's a special variable that is passed in to this Cypher query. So this refers to the currently resolving object. So whatever business is being resolved, it's bound to this variable inside of these Cypher statements in the Cypher directive field. So it's saying, okay, for the business that we're currently resolving, find all of the reviews and calculate the average. So let's see how we can do that. So I'm going to switch back to GraphQL Architect and toggle on the editor. And I'll just add this on the business type directly instead of using that extend functionality, but that would also work. And I'm going to say average stars. This is going to be a float. Add our Cypher directive field. And I'm going to say match incoming reviews relationship. Find the review node. Let's toggle that sidebar off. Return average of r dot stars. Okay. And let's restart. And now we go to the editor. Let's get all businesses, their name, and average stars. Cool, now I'm seeing some values for the computed average stars. You can even order by those. Oops, don't want the schema. So order by average stars descending. Cool, so all of these businesses, we have a lot of 5-star reviews here. Cool, so that is an example of a computed field using Cypher. And you can imagine the types of queries that we can write here using Cypher. Question from Robert. Is there a reason to use extend versus putting it directly into that initial type definition? Are there scenarios you don't have access to the type definition? Yeah, that's a great question. So in this case, we have a single type definition file, essentially. So this is just one big string that we're building up, which is being passed on somewhere to this GraphQL integration. We would want to use the extend functionality or the extend type syntax in the case where we have multiple of these schema definition files that we're then concatenating together. So it's very common to sort of co-locate the type definition for maybe some subcomponent with some logic. So for example, maybe you have like all of the user information in one type definition file and all the business information in another type definition file. And when you're starting your GraphQL server, you can concatenate those together. But maybe from the part of your application that is interested in the user part, maybe it wants to add a field onto the business type. So it could do that using that extend functionality and keep that co-located with the user functionality. Maybe it's like a type that is, I don't know, maybe some sort of field for a specific type of user, maybe like being able to connect businesses to maybe like super valued customers, or I don't know, something like that, where you want to add that logic in the domain of where you have your user definitions. So that's one reason, is when you have multiple files that you're using to separate out these type definitions. And then the other is, yeah, so to get at kind of what you're hinting at there, are there scenarios you don't have access to the type definition? Yeah, so there may be some, well, I should say, depending on what GraphQL tooling you're using, there may be some fields and types that are added to the schema that aren't explicitly declared, which we actually have quite a few of those here, right? We have some that are being added by the Neo4j GraphQL library that we haven't explicitly defined here. So things like the point type, things like the datetime types. So if we wanted to add a custom field in those type of scenarios, we could use that extend functionality where we don't actually have the explicit declaration of that type. Another one, so one thing I want to add to GraphQL Architect is kind of a separate tab here for your custom logic. So because it's really nice to point GraphQL Architect at a database, click this Infer Schema button, and have those type definitions generated for us. Currently, it'll overwrite any changes that we've made. So if we have a Cypher directive field here and we hit Infer Schema, it'll go through that process again and overwrite this. So one thing I want to add is another tab here that we can add our Cypher directive fields using that extend type functionality. And then we could be free to, in this tab, run that Infer Schema process over and over again as we update the database. So a way to sort of update the data in the database, update the GraphQL model without touching the custom logic that we've added. So that would be another case for that extend functionality. Okay, cool. So I think we have another exercise. So this next one is using the Cypher schema functionality to add a recommendation query. So what we want to do first is write a Cypher query to recommend businesses for a user. So there are lots of different approaches that we can use to write these types of queries. We can do something like, okay, look at what businesses the user reviewed, what other users are reviewing those same businesses, what businesses are those users looking at, those might be interesting to our first user. We could look at Jacquard similarity from graph data science. So lots of options there. So take a few minutes and think about how you would write a Cypher query to recommend businesses given a user, maybe looking at similar ratings, that sort of thing. And probably want to use Neo4j browser for this. So what I like to do for this kind of thing is in Neo4j browser, just pick some user. So match user with you limit 1. And then here's the real query I'm interested in. So match you ... And then this piece, what I want to do is then add a new field. This says movie GraphQL type definition, but this should say recommend businesses for a user. Let's do some live editing here of our instructions. So this says create a new field recommended to the user GraphQL type definition that returns a list of business objects that are recommendations for that user. Right, so essentially what I want to be able to do is as I'm resolving a user, I want to be able to add this recommended field, which is going to give me a list of businesses, and it's going to run a Cypher query to figure out what are personalized recommendations for that user. So it's up to you how you want to come up with that recommendation in that Cypher query. So that'll be some fun, but essentially what we want to come up with is on the user, we want a recommended field. It's going to give us an array of businesses. And we're going to have some Cypher query here that is going to find personalized recommendations for us. Cool. So let's put some time on the clock. This says 15 minutes. But we are a bit behind on time. This is kind of an important one. I'll put maybe 10 minutes on the clock so that we don't completely run out of time. But I think this is a fun one. So try to come up with a recommendation query, adapt it so that it works in the context of that Cypher schema directive. Remember this keyword that refers to the currently the user being currently resolved. For bonus points, add a field argument to specify the number of businesses being returned, so that I could say in my query, I could say, recommended, give me the first 10. And as a hint, any arguments specified here are passed as parameters to the Cypher statement. I'll link the docs page on this. So in GRANDstack .io. There is a page on GraphQL schema directives. So, or what I want specifically is this one, defining custom logic. This one, yeah, Cypher GraphQL schema directive. So I'll link that in the chat. That might be helpful. Okay, so we will take 8.5 minutes to dig into that. If you run into anything, let us know in the chat. Okay, so that's our 10 minutes. How did we do? Did anyone get it working? Something they're happy with? I see a question. Can we mix the returned type of objects in the Cypher directive? Yeah, so imagine that you have a Cypher query for generating recommendations that produces a score, and you want to return maybe the recommended object and the score as well. So you can do that. You would just need to create a new GraphQL type that maps to what you're returning. And then I think you would also need to project out your Cypher query to return an object that matches that structure. So for example, let's say your Cypher query returns something like business and a score, something like this. You would then need to add like a, I don't know, type scored business that has the score and the business. But then what you would need to do is project these out to an object. And this would be whatever the value is. So something like this would allow you to do the kind of thing you're talking about, if I'm understanding you correctly. The reason you have to project out this business node into an object is the current functionality in the Neo4j GraphQL integration won't expect there to be a node object embedded in here. So we had like B, and B was a node object. I don't think it's smart enough to then handle like a nested selection set on that business node. But yeah, that's something that this certainly works with scalars. If you have like, I don't know, score, and then if this is like, I don't know, maybe like an address or something that's just a string, yeah, that works just fine. And what you'd return is something like this. And you know, these can be Cypher variables too. This could be like, I don't know, function of something as well. So it works better with scalars than it does with sort of embedding node objects in what you're returning in the Cypher statement. But you can kind of get it to work. This feature was originally added for these sort of computed fields and to be able to return nodes that mapped into the type system rather than to return like projected out objects. So we should maybe have a look at that implementation to address some of these more complex things like what you're describing. But yeah, that's a good question. Cool. Okay, so who has a Cypher directive query that's finding recommendations for users that they want to share with us? Anyone get something that they're happy with that they want to share in the chat? Okay, I'm not seeing one from anyone, so I will just use an example that I wrote earlier. We're running a bit short on time. Let me just copy and paste it in here. So it's a bit long of a pattern. We can just bring this out. Oh, right. So 3 double quotes, I think, should give us multi-line string. Statement 1, 2, 3. 1, 2, 3. Here's our Cypher statement. There we go. Okay, so 3 double quotes in SDL gives us multi-line string, just like Python. Is that the Python syntax? Okay, so first let's just see if this works. So let's restart our GraphQL API. So it's running. So now, let's do this just for the first user. So here's some user named Will. Let's get the recommended businesses. And it recommends Hanabi, and I can do, location. All right, so I can do a nested selection on that node that comes back. Let's do this for all users. And notice we have a first argument here. So maybe just give me 2 recommendations where I have them. So Will, we only have 1. For Jenny, we can come up with 2 recommendations. Okay, so that seems to be working. Let's look at the Cypher query to see what this is doing. So this is on the user. So the statement is match this. So for the current user that we're resolving, find the reviews that user wrote. What businesses are they writing reviews of? Find users who have written reviews of the same businesses, and then look at what businesses those users are writing about, where the currently resolved user has not written a review of this business. And count the number of paths as the score and order by that score. And then here's where our field argument comes in. So any arguments that we pass to the GraphQL field, so in this case first, which has a default value of 3, that's how we define that in GraphQL SDL, are passed into the Cypher query as Cypher parameters, which we use this $ syntax to reference. So this query then gets executed as kind of a subquery for the overall generated query. Okay, cool. Robert says, could you do a conditional limit if you didn't want to default first to 3, but return all? So something we could do there, if we don't specify a default value, zoom in a little bit. If we don't specify this default value, we could we do a coalesce here? Something like that. I think that might give us a syntax error. If we don't have a value for first. Let's try that though. Let's see what happens. Yeah, cool. Looks like that worked. Cool. Any other questions or thoughts on this one? This again is definitely my favorite Neo4j GraphQL feature. There's a lot of powerful stuff here. I mean, we could have done a more complex query using graph data science or something using APOC. So there's lots of cool things we can do there. So the bonus thing here was to write a new mutation field where the logic is defined using Cypher that bundles up all of this logic. So remember when we wrote those mutations, we were looking at doing a bunch of different operations. And instead of doing a bunch of operations, maybe we just want to call a single mutation, define that logic in Cypher. We can do that as well. We're not limited to just fields on, say, like the user type that we've defined here. We can also define a mutation type, and maybe this is like add all, and it takes like a user ID and a business ID and maybe renders list of businesses. We can define any custom logic that we want in here with Cypher to do mutations as well, and also for queries. There's some examples in the documentation that look at full text index for query fields where we want some more powerful functionality than what we have in the built-in filtering. So I'll link that in the chat as well, because I think that's a great example. yeah, custom top-level query fields using a full text index. That's a great example of where we can leverage Cypher to do more complex operations, even at the root of our GraphQL API. Okay, cool. Well, that is the first module completed. We have 30 minutes left, it looks like. And there were 2 more modules that we had planned to get through. The next one is looking at the full stack part of this. So far we've just been looking at the GraphQL piece as it applies to Neo4j. The next step is then to see how we actually can use this Neo4j GraphQL.js library in code with a React application and deploy that. And then the third one is taking a look at some authorization features. So since we have 30 minutes left, let's jump into module 2 and then get started in the exercise. And if you need to take a break, we can do that during the exercise, since that will come pretty quick here. Okay, so far we've been talking about building a GraphQL API backed by Neo4j, and we haven't really looked at the code for how we do that. We've looked at the API that's generated. We looked at this GraphQL Architect low-code tool. I guess one thing I should mention is that in GraphQL Architect, we have the ability to export our project either to the file system or coming soon to export that to GitHub, which is nice so that we can hook into anything that deploys via GitOps, like Netlify or Vercel, those types of services. But how do we write this code ourselves? What's actually going on? So here's sort of the typical architecture for a GRANDstack application. So GraphQL, React, Apollo, and Neo4j database. We've seen how we do this piece, the GraphQL API on top of Neo4j. Although we haven't looked at the actual Node.js code that's running. We've talked about this Neo4j GraphQL.js library. But in this section, we'll see how to actually use that to create these GraphQL APIs. And then for the front end, we have a React application. So if you're not familiar with React, it's a JavaScript framework for building client applications, building user interfaces. There is a package called Apollo Client that integrates very nicely with React. We also use Apollo on the server side, the Apollo server library. And so the functionality we get here with Apollo Client is basically the ability to bind state in our React components to the result of GraphQL queries. Apollo Client has a cache that can also cache queries client side as well. So that's the general architecture of what we want to build when we talk about a full stack GRANDstack application. And there's a command line tool called create GRANDstack app that gives us the ability to quickly skeleton out and configure one of these applications. So we run this by running npx create GRANDstack app and then the name of the new application you want to create. npx is part of the npm toolchain. So if you install npm, it comes with that additional command npx, which is basically for executing node packages. So you don't have to install create GRANDstack app. You just run that npx command and that will download the latest version. And you see there's this little interactive prompt for pointing it at your Neo4j database. There's also different implementations for the front-end client. So there's React with TypeScript, and there we have now Flutter, Angular. So if you are interested in building a integration for the GRANDstack starter using a different framework, definitely take a look at it on GitHub, and you can send us a PR. I think we link to the starter project. Maybe not. I'll drop a link to that in the chat. So it's in the documentation, the GRANDstack starter here. Okay, so what we want to do with this next exercise is use the Create GRANDstack App CLI tool to create a GRANDstack application and point it at the Neo4j sandbox instance that we created in the previous module. So you'll want your connection details for Neo4j Sandbox, the Bolt URL, username, and password, which will be prompted for. So run this command, npx create GRANDstack app, the name of the application you want to create, or if you're using Yarn, the syntax is a little bit different. You leave off that dash and then follow the commands to start the project. And you should see something like this. Once we get that running, then we'll take a look at the code and we'll see how we can modify this to take advantage of that recommended field that we added to our API. If you run into issues, if you don't have Node installed or something goes wrong with npm, you can run both the API application and the React application on Code Sandbox. So if you just click one of these links, it will pull that down from GitHub and give you an online environment with the code that you can then fork and run in the browser. So if you have any Node npm issues locally, I would suggest you just try that Code Sandbox. It's the same code. But anyway, let's take some time to get that running. This says 15 minutes. I think we can do this in 5 minutes. So we'll put 5 minutes on the timer. If we need to take a break, do that now. And then in 5 minutes, I will go through this myself, and then we'll take a look at the code and see what changes we can make. Question from the chat, do you plan to add Vue.js framework too? Yeah, I think Adam had started to look at a Vue version of the GRANDstack. So I think we'll have that at some point. But yeah, if you have any ideas for other frameworks, definitely let us know. The R in GRANDstack is, it stands for React, which is, the opinionated thing to start with. But, certainly once you have the GraphQL API, that's one of the great things about GraphQL is once you have that API layer, you can build different client applications that interact with that API. It seems to me that a lot of the client tooling starts initially around React. So Apollo client, by default, I think you get their React integration, but there are different clients for different frameworks as well. Oh yeah, great. And Adam has linked his Vue version there. Cool. And then another question in the chat. Can you tell us anything about a mechanism for subscriptions, a way to stream changes in the database? Yeah, so subscriptions, we said earlier, are sort of GraphQL's built-in pub/sub functionality for pushing out events as they occur. There's nothing built into GRANDstack Starter or Neo4j GraphQL.js that gives you subscription functionality out of the box, but I know some users have added subscriptions using Neo4j GraphQL.js. There is Apollo subscriptions WebSocket. Which gives you this pub/sub, Apollo pub/sub that you can publish events to. And so in terms of triggering events, there's a few approaches to do that. One is essentially anytime a mutation is executed, to then publish an event and trigger a subscription that way. And that works if the only changes to the database are coming in through the GraphQL API. But that may not be the case. You may want to publish events depending on some writes to the database that are coming from another system. Maybe you're executing Cypher queries. Maybe you have some background worker that's going on. And so for that approach, a few users have used transaction event handlers in Neo4j, so kind of like triggers essentially in Neo4j. And then those transaction event handlers, when some data is updated according to some criteria, those transaction event handlers, so that's custom Java code that's deployed to the database, those then make a post to the pub/sub functionality, which then pushes out a subscription event. So I think in terms of the ease of implementation, using this Apollo pub/sub WebSocket example to connect that to a GraphQL mutation is, I think, the most straightforward. I was playing around with this a while ago, and I've been meaning to push this up to GitHub and share the example. It's sort of proof of concept. It's using actually directives for the subscription implementations. So I'll post that up to GitHub. Oh my, there's my timer. With that example, but yeah. Anyway, that's sort of the spectrum of how you can implement subscriptions using Neo4j GraphQL. I guess a third option is, and this is what some database GraphQL integrations like Hasura, for example, simply pull the database. So you have the database query as a result of the subscription, and then you have a mechanism that's just pulling the database, looking for changes and publishing those as an event. So that would be another way to do it. There's lots of options there, I guess, depending on your needs. I think at some point we'll put out some maybe more opinionated ways to get started with subscriptions. Yeah, that's definitely something that is useful. It's a good question. Okay, cool. So our time was up there. Let us take a look at create GRANDstack apps. So I need a terminal. Here we go. Okay, so I'm going to run npx create GRANDstack app. Let's call it Fullstack GraphQL workshop. And this will now ask me if you haven't run this before, I guess it will download the latest version of Create GRANDstack app from npm. This is just an npm package. Create GRANDstack app. So it's just published to npm. So when you run npx create GRANDstack app, it fetches the latest version of that package and executes that. And now it's asking us what template we want to work with. Let's use React. You want to install dependencies? Yes. Create Git repository? Sure. Says now we need a database to connect to. If you don't have one, we can use Sandbox. Great, we already created a Sandbox instance. So I want to go back here. Let's grab this Bolt URL. Oops. Use an encrypted connection. No. Enter the user. User is Neo4j, and the password is right here. Okay, so now this is going to download the latest release of the GRANDstack starter project from GitHub, and it will then install some dependencies. So first it's installing the GRANDstack CLI. We haven't talked about the GRANDstack CLI, but it's actually something we've been using already. It's actually functionality that sits under GraphQL Architect. So the GRANDstack CLI is bundled with GraphQL Architect, and anytime you go to, say, infer the schema from the database or start the local GraphQL API, it's running commands in the GRANDstack CLI. And the GRANDstack CLI, let's take a look. Code for that is on GitHub, GRANDstack CLI, this one, yeah. And so what this is doing is it's basically exposing some functionality. It's not everything is quite implemented yet, but basically helper functionality and utility functionality for working with GRANDstack applications. So for example, we can use it to start a local GraphQL server if we pass it connections to a database and type definitions. We can give it the infer schema flag, and we don't even have to pass it GraphQL type definitions. We can just run this command line, run this command, point at a database. It will infer the schema and start the server for us. We can also use it to sync constraints and indexes based on our schema. There's some deploy options for deploying to GitHub or Code Sandbox and so on. So sort of lots of utility functions bundled up in this command line tool. Anyway, so that's being installed, and then there are dependencies for our API application and then for the Web React application. Okay, so now to start it, cd into the directory, run npm start, and then we can optionally seed the database. Well, we've already seeded the database. We added that sample data set to our Sandbox instance. So let's cd Fullstack GraphQL workshop. Let's open this up in VS Code and take a look at what's going on here. Let's get a terminal. And npm run start. Cool, so this is going to start two applications. One is the GraphQL server, which it says is running now, and then also the React application, which is still building. So let's take a look at the GraphQL application. So that was running at localhost 4001 GraphQL. So we have our familiar user business review category data set and GraphQL API. So here we can search for all of the users that are in the database. Cool, that looks good. If we switch back here though, we can see in the logs now, this one. This is the Cypher query that was generated from that GraphQL request. So we can start to see what's going on behind the scenes here for those generated Cypher queries. And there are a few more down here. So I think that means our React application. Uh-oh. Our React application did not work. Why is that? Oh, because do we have a user without a name? I think oh, I see. I think we made an assumption that every review is connected to a user. Let's fix that. So if you remember here, when we added this business, we added a review for the business, but then the review is not connected to any user. In our React application, is not smart enough in the example that we wrote to handle the case where we don't have a user for the review. So let's fix that. Let's attach a user to this review. So let's run a mutation to add user wrote. So from the user input, user ID, U1, I think is one of our users, and then 2, which review input. That's the review ID that I just copied. And we have a from, and a selection set. So we run that. Okay, so now that review should be connected to a user. And if we refresh, here we go. Cool. Let me paste that mutation that I ran. So if others are having that same error, try running that to connect that dangling review to a user. Okay, so here's our GRANDstack application. So there's 2 views here. There's this dashboard view, which has a few components. One is this simple chart that's showing us the rating distribution, counting the total number of users that we have, showing us the most recent reviews in a table, and then user search, where we have some filtering functionality by name, as well as some ordering functionality. Okay, cool. So let's take a look at the code here. So we have 9 minutes left. Let's start looking at the API application. And we'll look at index.js. So this is the Node.js API application that is using Apollo server. It's pulling in the Apollo server Express flavor of Apollo server, specifically so that we can add middleware, Express middleware functionality to it. We're pulling in the Neo4j driver, and then the package that we're really interested in here is Neo4j GraphQL.js, where we are pulling in this make augmented schema function. We're also reading type definitions from GraphQL schema file, which is here, which has our type definitions. You can see we have a few more cipher directive custom logic fields that we've added. But back to index. Okay, so we are passing to this make augmented schema function that we're pulling in from Neo4j GraphQL.js. We are passing in the type definitions and then some configuration. The configuration here, we're excluding some types. So I think someone had asked earlier about having Cypher directive fields basically return types that don't exist in the database, or like projecting out types. We have an example of that here, which is this rating count type. So we have a query field here, ratings count, which returns a list of rating count objects defined as a Cypher query here. And essentially, this is what is the data for that histogram chart. So we're looking at all of the reviews, doing a group by on the stars to get a count, and then this is the object that we're returning. So key stars, key count, that matches the rating count type in our GraphQL schema, but this does not map to a rating count node label in the database. So in the configuration object that we're passing to make augmented schema, we're excluding that from the query and mutation augmentation process. So we don't want to generate query and mutation fields for that rating count to try to look it up in the database. We create a Neo4j driver instance to connect to our sandbox database. We initialize the database, so this is going to assert any database constraints and indexes. And then here, we take this schema, this executable schema object that we created from the call to make augmented schema, and pass that to our Apollo server instance. The other thing we want to do to pass to this Apollo server instance is inject a Neo4j driver instance so that when we execute these GraphQL operations, they can look in the context object inside that generated resolver function and have a connection to the database to execute those generated queries. And then we start the server. So you'll notice there's no resolvers that we're implementing here. So we haven't had to write any code that says how to actually fetch data from the database. That's handled for us by this make augmented schema process. Then on the React side of things, if we look in web React, source, index.js, so I won't say too much about React in general. There are a lot of good resources out there, and we're short on time at this point. But I want to point out just a couple things specific to how we can use GraphQL in React. So we're using Apollo client here to connect to our GraphQL API. And so we need to specify the URI, the GraphQL endpoint. And then we need to inject this Apollo client into the React component hierarchy. And so Apollo provider is a component that lets us do that. So we instantiate the client instance, inject it into the React component hierarchy using this provider pattern, which uses the React context API to then make this client object available to any child components, which our main app component is in here. So then inside any of our components, we can make use of Apollo client. Let's take a look at it at the simplest example that we have, I think, which is the user count component. So this is the component that is rendering this piece of the dashboard. So it's executing a GraphQL query that just says how many users do you have in the database. And to do that, we're using the use query Apollo client hook. So to do that, we define the query. It's very simple. It's simply the user count field. And then inside our functional component, we pass the GraphQL query that we defined to the useQuery hook, which then gives us loading, error, and data objects depending on the state of the query. So if there's a loading state, we can return a loading message. If there's an error state, we can return an error. And if we have the actual data, then we can render the actual count, which is here, data.userCount, which shows up right here. Cool. Well, I think we're out of time. That was a very brief overview of the GRANDstack Starter project. If you'd like to continue on with the workshop, the next thing that we were going to do is take a look at how we can add a recommendations field to our table in the user search here, so that for each user, we're showing them the businesses that they might be interested in. And then deploying to Netlify. So Netlify allows us to deploy our applications, static React sites, but also Lambda functions. Inside the GRANDstack starter, there is a Lambda version of the GraphQL API in functions GraphQL.js, and all of the scripts to build and deploy that on Netlify or Vercel are included. It uses the Apollo server Lambda flavor of Apollo server. So that's what we missed in this module, and then we completely missed the authorization section where we're taking a look at JSON Web Token and how we can use GraphQL schema directives to protect our API, and then also how we can use some middleware to pull in some of those values from a user token into those Cypher directive fields. There is a documentation page that covers some of that here, the authorization and middleware page, which I'll link in the chat as well. So I'm sorry we didn't get to all of that. Maybe we'll put together the second version of this or something like that that covers authorization and maybe subscriptions as well at that point. But cool. That's all the time that we have for today. So yep. I guess we'll leave it there. Thanks everyone for joining.
Thank you very much, Will. We really appreciate this session and all the work you've put into GraphQL and GRANDstack and all the contributions you've made to our developer community. And thank you also, Adam, for your assistance with questions. We'll be posting a link to this training session as we recorded it, and we'll also post a link to the content that Will referred to. Thank you all for joining this session, and I hope you all have continued success with GraphQL and GRANDstack. And as a reminder, please remember to register and attend our online developer conference, Nodes 2020, on October 20th. We have over 9,000 folks registered right now, and the number grows every day. So we look forward to seeing you at Nodes. And again, thank you very much, Will, for this excellent session. Bye, everybody.
Cheers, folks.